With over 90 million people diagnosed and 9 million recorded deaths in 2015, cancer prevalence is continuing to rise throughout the world. Cancer is defined as the disease of abnormal growth of cells with the ability to metastasize to other parts of the body. With increasing frequency, approximately 38.4% of both men and women will be diagnosed with cancer at some point during their lifetime. Often an adapting and complex disease, cancer can be defined by 10 proposed common characteristics or hallmarks. These hallmarks help map cancer's ability to hijack and use our own cells and pathways to ensure their survival. Of these hallmarks, the most effective tool that cancer has is its ability to evade the immune system. Fortunately, new therapies have evolved that re-engineer our immune system for a more effective battle with cancer. The immune system is a defense system that protects an organism against disease. Our bodies are constantly under surveillance by immune cells that circulate and patrol for threats. B cells are part of the adaptive immune system and release antibodies, which in turn label the foreign or defective cells for destruction. Macrophages and natural killer cells constantly survey the environment, watching for antibody-labeled cells and destroy them. Cancer cells have developed a variety of cellular and molecular mechanisms to avoid immunosurveillance. One of these mechanisms is the defective presentation of tumor antigens on the cell surface, making the immune cells fail to recognize these cells and therefore not target them for destruction. One of the ways the immune system attacks foreign substances is to make a large number of antibodies. Antibodies are proteins that are produced by B cells and circulate throughout the body in the bloodstream to locate and bind specifically to antigens on the surface of problematic cells or foreign substances, triggering cell destruction by other immune system processes. Monoclonal antibody therapy is a type of immunotherapy that enables the body's immune system to attack cancer cells. Researchers can design antibodies that specifically target a certain antigen, such as the ones found on cancer cells. Once the antibody is attached, they can recruit cells of the immune system to destroy the cell containing the antigen. Monoclonal antibodies are man-made proteins produced in the lab. First, a mouse is immunized with the antigen of interest, which allows its spleen to produce plasma cells to secrete antibodies against the antigen. Next, the mouse spleen is removed and B cells from the spleen are isolated and mixed with myeloma cells. Cell fusion is induced to produce B cells, which grow at the rate of myeloma cells to produce large amounts of the desired antibody. After, cells are transferred into special media, which the hybridomas that produced antibodies specific to the antigen of interest are selected and grown in bulk. These monoclonal antibodies are collected and purified.